Hi, I'm Tyler. I've recently been going through a course called CS50 from Harvard, just to learn more about computer science. I'm predominantly like a Node.js, like JavaScript developer that uses like React on the front end and then uses like Node.js on the back end with like an Express framework. So I thought it'd be cool to kind of learn more about like how these compilers work. And what's cool about this course, it's free. So if you ever want to check it out, I'll link it below. But it goes through like several weeks of C, then even talks about like Python, SQL, which I have some experience with. It'd be cool to get another perspective on how that all happens. It goes through some HTML, CSS, and JavaScript. So that'll be a more easy week for me. But then he talks about Flask, which is that framework, that library for Python, and then it ends with like a final project where you can pull everything together. So what I was thinking is I could make some videos about like what I've been learning each week in this course, and then kind of share that with you guys as well, and maybe even do like a problem here and there and show you like how it looks to like code in different languages or like how I think through things. So let's without further ado, let's jump into it. Let's talk about it. So you'll see here I have it open. I have everything organized in these little folders with each week. I'm currently like wrapping up week 3, so I'll have a few videos we're making in a row here. But I thought I would go and check out a few of these things we went over and talk about what C is as a language. It's a very low-level language. There's a lot of conveniences I found with JavaScript that I cannot take advantage of here. But let's go through this file here. We call it hello in our lecture. At the very top of you'll find these like header files. Now if you want to use anything like functionality that someone else wrote, you need to include it in a header file. So a lot of times there are some things that are more like native to C. You'll see here CS50 is something that they made, so we get to make use of as well. And these have like all these types of functions you can use. I'll be going into more depth like how we can know what's in them, but we include them so it gives us access to them later on in our code. The compiler will know what's to pull from. Then when it makes the compiling of all the code, it'll be able to have those functionalities there without us having to define them ahead of time. Now next up we have this like int main. Now whenever you execute like a file after it's been compiled, this is just like uses the function that's called. So yeah, int main here. Int, we'll talk about more in the next one. This is just like you can return a number if you want to. And void here, they use void to say you don't need to input anything. It doesn't need to take any arguments, which is nice. And then we get more into the next line here. We'll have this like get string. This is something that's written by CS50. It basically prompts the user to give us a string, which we'll save in this answer. And what's unique here, and I've gotten more used to with TypeScript, is to use the string here to say what data type there is. Now there are several data types. You'll see me use them throughout these videos. But a string is a more like complicated data structure versus like a char, which is a character, which is just like a much less memory that takes up. But I'm just storing it here. I'm saying it's string, so now the compiler knows that when we talk about answer, that's a string. It knows this. It's not going to get confused later. And it just prompts it. Now, they say in the course, we'll talk about later about how they made this function, which I'm really interested in, how they get this user input and what goes into it. But for right now, we're going to take it on faith that it's going to get the string for us. It's going to save it here. And if you want to know more about how it works, what's cool about CS50 is they have this little manual here that you can show all the functions you'll be using throughout their course. You'll see it's not that long. So they're saying these are the most likely the ones you'll interact with. But they've included like all these libraries from across C that you can make use of. But we're going to stick with just what's frequently used here. Yeah, you can always click on one. Like for example, get string. It just prompts user for a string and lets you know what's going to happen. And what's get returned. It returns a string from the input, which is really nice, right? We could get what we need to there. So we'll trust that it works. And we'll move on. So now it's saved here, and then we do this printf, which from JavaScript is like your console log. It lets you see things in the console. So printf, we'll say hello, and then what's really cool I learned about is I used to use like variables inside these string statements, and you don't do that here now. At least not with this printf command. This printf allows you to put in. Let me go to it right here. It allows you to use these kind of what's the word I'm looking for? Format codes within them. So I have a string, so if I use this like %s, that just means that if I leave this here and an argument following the string I want to print, I just put what that string should be, and like it'll know that cool. I'm gonna print. I'm gonna take that answer, put it in for S, and it'll say hello. Yeah, I put a little few format codes down here because as I was learning, I was like, oh, that's cool. He was talking about them. Yeah, so int and then li is a long integer. This means you can have a larger integer. I think int is a cap on it, so if you want it to be longer than that cap, you can do that. And a float's more like a decimal, but you just put that little percent sign there, and it'll know to fill in that part of the string with that particular thing you put in as your argument afterwards. Now, once you've done all of this, you'll have to compile it. Now, I'll talk about it more in a future video because it's part of like the next week's lesson. But there is a command to compile the code. So usually they have one called make, and you say make, just put in the name of the file here, hello without the C. It'll compile it, and then you call in the current directory with this little dot slash, and then do hello. Whenever you do that make, it makes this file right here, which is now like a very low level code. You can check it out. It's not going to make much sense when you see it. I'm going to open it up anyways, this is why not, so you can see it, but it looks all crazy. But this is like this compiled code for the computer to run your program. We're not going to worry too much about what's in there because it's hard to read. It's not for us. But now that we've compiled it, we can run the command, and you'll see here that it's going to ask me for my name. Oop, I have a lot of commands here. And then I can put in a name, so Tyler, and when I hit enter, it'll save it here and answer, and then it'll run the next line of code, and it'll say hello, comma, Tyler. So enter, hello, Tyler, and there it is. So really nice. So cool, that's like the first program we write, the hello world of it all. And you'll see me when I do some problems later that there's this like standard sort of like structure, a lot of boilerplate that happens. It's a very verbose language, a lot of stuff you have to do for it. But let's check out another one here. Compare here. Compare the if, else if, and else statements work just as they usually would, which is really nice. This one here just compares numbers. It tells you what's x and y, and it'll compare them and tell you a statement about them, which is really nice. So what's cool here is I say if x is less than y, if, and then I'll follow it here. One cool, I think, notation syntax used in C is that these curly braces, this code block goes below the if statement instead of starting directly afterwards, like I'm used to doing here with like my JavaScript background. It actually just goes right below it. But yeah, cool. If it's less than, print out s is less than y. You'll see here this /n. This is a new line. This is to make sure that the code, your next line down here, terminal, doesn't start directly after the print. It'll push it down to the next line so that they don't like line up too much. Else if, meaning if statement didn't work, then check out this if statement. If it's greater than, run this. You'll see here I do not check if it's equal to. Else it's just catch-all block. It's just going to run x is equal to y. If it's not greater than less than, logically it can only be equal to. So cool. Conditionals work just as we expect them to in C, so that's really nice. A lot of similarities there. Next up, we're going to check out this catc. We made a program to meow. And what was cool here, we learned more about like what it means to define other functions within a file you want to use within this main file. Here I'm including the same things up top. I've been getting more used to just like leaving out what they are. It's like, oh yeah, this is like getting functions to get information, and then standard IO we usually use that to print things. Those are my print functions. I'm gonna come right back to this, but what we got used to now is when coding in C, sometimes you just want to keep things more simple, right? So let's say I run this thing. I want to ask the user for a number, a positive integer, and then I want a cat to meow that many times. So what we say here is you just want a positive integer. Now from CS50 they don't have one just for positive. They have a getInt feature function, which doesn't constrict it to only positive. So I'm going to write a function that gets a positive one. I'm going to store it here, and then I'm going to run it into another function called meow, which will meow the number of times, right? To keep this simple, small, and have these kind of actionable words. Now, in order to run this with getPositiveInt, I see here I don't want to plug in anything, so the input for getPositiveInt will be void, but I do want it to return and store into positiveInt an integer. So cool. So I'll put this up top. What this does for me here is I'm going to define these functions below the main, so I keep my main function up top. This lets the compiler know that this function does exist and what it returns and input. So when it runs the code for main, when it builds up that function, it'll be like, oh, I ran into this. You haven't defined it yet, but I'm going to trust that it's there. So we'll just call it. And the same thing too for meow. It's going to take an integer. I don't need it to return anything because it's just going to print those meows that I want. You'll see down here where we get to get positive int. What's really cool here is that we're using a do while loop. So I want to assign in a value. The variables are block scoped. So if I'm gonna have this like loop going on to grab a number, I need to initialize the variable somewhere. So I have this in, that's gonna be an integer because I want it to be a positive one. And this do while loop, the way it works is it's gonna iterate and go over and over until it reaches its goal, but it's always gonna do this first line here before it starts the loop. So here it's gonna get an integer from the user, and then it's gonna check, is this n less than 1, meaning is it 0 or negative, which I don't want. If it is, ask again and keep asking until they give you a positive integer that makes sense, and then return that in. This will go back up here. We'll store it here in positive int, then we'll meow that many times. Now let's build out the meow function, which I've hoisted already. It returns nothing, but I'll have int times, right? How many times we want to meow. We'll use a for loop, which works the same way as it would like in JavaScript. You're going to initialize a variable here that's going to count until the loop is over. Have a condition to let the computer know when to stop. If this ever becomes false, it's not going to run the code block anymore. It's going to move on. And then a way to increment to get closer to that goal to make sure the loop stops. Otherwise, it goes on forever. So this plus just means to add 1 to I over and over until you reach this conditional, which if we pass in a number, it's going to go up to that point. It's going to print meow with a new line every time. So let's go over what this is. So I've already compiled this code. I haven't changed anything, so I'm just going to run it. So .cat, how many meows? So let's try to trick it. So let's say we say -3. Now when we do this, it's right now it ran the code, hit this, got here, and it's running this line. I'm going to give it a -3. It's going to check this. It's going to be less than net 1. So it's going to run it again when I hit enter. There it is. If I do 0, again, it's still going to fail this conditional. And what's really fun here is that it's going to have to happen more than once. Because I do 1, I did leave this equal sign off on purpose to show you that even though I want 1, it's going to listen to me very well. Oh, while it's less than 1. Oh, yeah, never mind. I take that back what I said. That was a little mistake on my part. I thought I was going to fail. But no, it's while this is true, 1 would definitely not be less than 1, so it would move onward. But cool. It said 1. I take this 1 here. I return it. I'm going to save it here in positive int. And then I'm going to plug it in here. I will be 0. I is less than that number is what I'm looking for. So it starts at 0. 0 is still less than 1. So it prints me out 1, increments. I becomes 1. Now it's no longer less than 1. I only get that 1 meow. And if I were to run this function again and say, for example, 4, it'll print for 4 times. So cool. A cool way to use this do while loop to prompt, and then a for loop just to get all these meows to print. I thought that was pretty interesting there. I haven't used many do while loops with JavaScript, but when you're prompting, I feel like I see a lot of use case there. Now let's talk about just one more file here to go over a few more things. Let's talk about this calculator. Now this is very simple. It's a calculator that's going to divide things. So here I'm going to prompt the user for an x and a y. I'm going to do x divided by y. You'll see here I'm doing a few things. I'm prompting for integers. And when I do this, I will then want to print what's called a float. Now the reason why is that an integer does not have a decimal place, but if I'm dividing two things, most likely I will definitely hit like a wall, because if I do like 7 divided by 3, which I'm gonna show off here, if it was just an int, I couldn't have this decimal it's supposed to follow. That should be 2.3 repeating, and it is. Cool, because what I'm doing here is I'm calling it a float, and then this thing next to it's called casting. I'm going to cast this next division, even though these are 2 integers, as a float. I'm telling the computer program to be like, cool, you're dividing 2 integers, but I want you to treat them both as a float, so I get this decimal place. Now, if this wasn't here and I tried to compile the code, let's say let's make my calculator again, it's going to get confused and be like, wait. these are integers you're dividing. It's not a float, and you're asking for a float. What did you mean here? So the ways we can get through that, we can also put an I here, so we'll turn it into an integer, right? So we're dealing with two integers we're dividing. So I can make this calculator, so make calculator, it makes it. And if I run the program, 7 divided by 3, if I keep it as an integer, you're going to encounter something called truncation. We know that's 2.3 repeating, but it's treating it as an integer, so the computer does not go beyond that 2. The division that has a calculation that keeps going, but it's like, no, we're going to stop because we're just looking for an integer. We got it right away. So that's called truncation, which you could use to your advantage in some scenarios, but most of the time it's going to be a hindrance. So you have to always keep in mind what you're expecting from your output. If you only want an integer, you want it to be just that, then yeah, you can keep it this way. There are some other ways to take care of this. I could switch this back to a float, and let's say I were to change both of these up here to floats. Cool. Well, let's double check, right? The manual, right? This is called getInt, not like getFloat. Will this be okay when it returns? So I'm gonna go check here in the manual, and it says here the return value, it turns it as an int. All right, cool, and we're saving it as a float. So what's gonna happen there is that it's gonna automatically put this like 0.0 on it to turn it into a float for me. I can also use the function called getFloat if I want to make it a float, but let's say I would just do one integers. But that int should be fine. It's not going against any rules here. So now if I do this division with this float here, then if I make this calculator, again, you have to compile each time. It's something I've definitely taken what's the word I'm looking for, like an advantage of with JavaScript with my Node.js environment, because it kind of does this for me every time I just run Node. But if I run this calculator now, if I do 7 divided by 3, 3, it'll divide just as normal. But what's cool about doing it this way, by making them floats, or even if I maybe even casted it earlier, it could be fine, is I can also control the number of decimal places. So if I do a 0.2, for example, it'll only give me 2 decimal places for my float. So it'll truncate it a little sooner. Say I only wanted to, it'll do that for me, which is super fun, right? I have a lot of control here. I used to do a lot more other functionalities with JavaScript to pull this off, like pull in other math functions. But here, I just say how many I want. So 7 divided by 3 again. Look at that, 2.33. And it can go on and upward, so I can do 10. And I'm going to do 10 on purpose here because we're going to run into a fun thing with C, with overflow when I do this. Boop. So 7 divided by 3, which should be 7.3 repeating. But if we go too far, the computer's gonna get these like kind of really big numbers, and it's gonna be this like overflowing effect to try to make sure it can keep this decimal going, and it'll start to like fall apart a little bit here. So that's something you have to keep in mind too, with how specific you want to get. Maybe you might need to use a different coding language, but I think this is a problem you probably run into with computers often because there's only so much memory they're gonna hold for stuff. But I thought that was cool. So you can start to control how many decimal places you want. So if you like want to base off a lot of your calculations around just 3 decimal places, then there you go. Just use 3. That's where this lesson kind of left off. What is cool is that, again, I'm just going to run this one more time just to show the 3 decimal places because I think it's awesome. They have problem sets. Now, if you're taking the course you want to, I would definitely avoid that next video I'm going to make where I'm going to go through one of these problems. But it can give you some cool insight. So if you plan on taking the course, please don't watch it. But if you just want to check out what it looks like, you can watch the next video I'm going to do on one of the problem set problems. Because you'll see here, I've already done 3 of them. I did Mario More. There was a split where you can have a choice between Mario More and Mario Less. And I chose More because more of a challenge. I wanted that. But now it leaves me Less that I can show you guys. Could be something fun. That'll being said, thank you so much for watching. I want to continue this. I hope you stick along for the journey. I want to show you that we are always learning here as developers. So join and come see the world of C that will eventually turn into Python, and we'll make a cool project with it. And you'll see like my honest reaction as we go through. And again, please check out CS50. It's free. You only have to pay if you want like a certified like certificate of like completion, but it's a free course if you just want to learn about computer science. And so far I have a lot of cool fun facts throughout it that you definitely don't want to miss. This video here has only been what looks like 20 minutes. These lectures are like 2 hours long. There's a lot of cool content, and David's a really like, smart person. He's a very great teacher, so I think you'll enjoy it. So anyways, I'll see you in the next one.